and this will be the mean position of the simple harmonic motion of this harmonic oscillator spring mass system. There is no friction. So you can easily calculate the time period, and once we have the time period, we can calculate time period by 2, because the block goes from here to here, comes back here. That is time period by 2. Full cycle takes 1 time period, so that the full cycle would be going from here to here, then coming back. But we have to consider the time when it has moved from mean position to here and then back to the mean position. In that time, that is t by 2, how much this block has traveled after hitting block P. So that's a question that has been asked in IIT JEE Advanced 2018. That was 2 weeks back, and I was thinking about this and thought of making a video, because I am making this video not to just discuss the problem and the solution, but to discuss the concepts, the physics behind it. So as you would see, the answer is very easy. You can calculate the distance by multiplying the velocity and time, because velocity is constant. So but I've gone a step further. I was thinking, if this block, somehow I can make this block collide with block P repeatedly and conserve the energy at the same time, how can I explain the concepts of physics? Each collision, what's happening? For example, after it has made n collisions with block P, what will be the amplitude x this block P? So let's get back to the original problem. Then we can modify this by putting a elastic wall here, so that this block hits the wall, comes back with the same speed, hits it, goes back, hits it, goes back, hits it, like that. So the IIT question, the answer that was needed in the IIT exam was kind of an average ask. So the time period for this oscillator, that doesn't depend on the velocity of this block, doesn't even depend on the velocity of this block, because it doesn't matter whether it hits with velocity 2 meters per second or 20 meters per second, or or even its mass. If it's 1 kg or 10 kg, it doesn't matter at all. All that matters is, time period t is 2 pi the root m by k. So the time period for this spring mass system will depend on the mass, that is 2 kg, the spring constant, that is 2 Newton per meter. So let's calculate the time period, which will